Okay, this is you can't see it very good, but I need better light. But I've got a magnet wheel here that is balanced. See that? Now I've got holes in it all around. There's 10 magnets, but there's with holders, but there's actually 20 holes, so I can put 10 more, which I already have. But I wanted you to see the balancing. Now these motors like this, uh, these scooter motors are all you need, and pulse it. You could use some different types of pulsers, or you can rewind them to pulse. And this is like Thane Heins generator wheel, and then I'll be using Turion style coils, but they'll be C-shaped, which will go on each side, which will be self centering the magnets, so there won't be so much structural difficulties in centering the magnets. And these are pipe nuts and pipe uh, holders with pipe nuts, and then the magnets press in. But I wanted you to see how free with the bearings. I should really get a better picture for you here. Hang on a second. And also you can use these motors, just two of these motors faced off together possibly, and there's a way you can wind the generator side. I haven't tried that yet, but right now I'm still working on this, balancing this wheel and getting all the hardware for it, which I'm very slow at doing. This is for my younger son. Now you don't need a machined wheel. You don't need a lathe. You can get a saw blade and these hubs. You can see these hubs maybe, huh? If I go like that, and these little bearings, and this right here is a coupler, and it flexes, and you can put that to a motor. This is 10 millimeter, and so is the motor over here. That's a 10 millimeter shaft, so these hook right on. You'll have to cut that thread off there and just put that up there. But mainly I wanted you to see that when I was I cut these pipe and drilled them so I could press my magnet, and then I got nuts, and then I don't have a machine shop, so I cut them at random, and there are different weights to them, and originally it would like droop down to one side, and I had to keep switching the magnets around and trying to get them on each side better, to where it's well balanced, and I've achieved that. Now the next step is to make some C-cores. Well, they'll be almost square, like Thane Heins has, which helps, and there'll be a great big Turion style coil that I've already shown that, and on my bigger wheel. But this is for my son's school project, because we homeschool. So I wanted my son to be able to, I'll take this all apart and I'll let him put it together, and once I make all the pieces, and then he can experiment in science class with that. Anybody can. And so the way that it works is you have 10 of these magnets, and you'll have 9 coils possibly, so that instead of having a coil over each magnet position and making it impossible to unlock, it'll be like you'll need a crowbar to turn that shaft, like Muller showed us in his motors, which these won't have those type of coils, but we're using his, I'm going to use his strategy possibly as one strategy to still have a lot of cores interacting, the C-shaped core around there with a big coil interacting with each magnet, but no lock, hardly any lock, magnetic lock. That'll be the next stage, where I can just go like this, and it free spins, you know, fairly easy. And I'd like to show a lever on there with pounds to see how many pounds it actually takes. Show you that. But a 7th grader, you know, somebody 14, 13, 14, 15 could take one of these saw blades and drill holes in it, and I ended up buying threaded pipe already for about the same price as regular pipe. So, and then I just put the drill down the pipe to fit this magnet here, so anybody can do it. And then you need a scooter motor, and you need your coils, and we'll get to that. So I wanted you to see how nice this baby floats. So that's a step in the right direction, where it doesn't just keep going around at a dead spot. See, there is some slight variation, but when I spin that, and this is not bolted to anything, it doesn't just jump all over. You know, that's important, because when you wind it up, you know, you don't want a vibrating wheel. So as long as you take a little care with drilling your holes, and I just use a magic marker and a ruler and stuff like that, and got it close and drilled it, and there was some drift and stuff. So, and like I say, nothing is machine precision within 1/10 of a thousandth or something. This is just anybody can do this stuff, which is what I like, because I don't really have time or a machine shop to do that. But you can see it was possible to make a very smooth running. And this shaft and these bearings are like $10, and this hub is $5 or something. I got 2 hubs on there and a washer. So I use a washer, and then I also have a shim washer, to center precision shim washer on the inside of where the wheel meets the shaft, like you do on the rotary cutting saws, you know, the table saws. You have shims sometimes, and this is a 6-inch, I think, 6.5-inch wheel, which should be able to generate some power, decent power with it. And but the main thing is that it will accelerate under a load. That's the goal, to get it to accelerate under load and not have so much magnetic lock. And this is defeating Lenz. That's the goal, is to defeat Lenz law, if you want to put it that way. But really it doesn't. It's really probably not the best description. But we know, most people know about Lenz law, and that they feel that it cannot be defeated. And of course we know better than that. And Tesla gave us coils that that do just what we're working on. So I wanted to show you the free floating there. And I got several of these other motors here. I'm not sure which one I'm going to use. Rewound motors. Okay, thanks for watching.